Hi friends, welcome to the Unit 2 Day 8 video. This time we're going to be talking about the products and quotients of functions. Products and quotient functions have domains that are similar to sum and difference. However, when we have the quotient function, we can't divide by whatever would make that function g of x equal to 0. So if I have f divided by g of x, then f of x over g of x, except g of x cannot equal 0. So we have a little bit of extra legwork to do for g of x in this scenario, whenever you're dividing. With multiplication, everything's good. We can multiply. It's when we divide. We've talked about this in the past few videos, but really I just want to hit that you can't divide by 0. So you're going to have to set whatever is your g of x in this division one not equal to 0 and then solve to get your possible domain. So for this one, for this first example and example 2, we're going to be talking about when we multiply. So we're multiplying an even root and an even root. So just kind of a heads up already, the domain of f of x. So I'm going to set 1 plus x greater than or equal to 0 and then solve. So subtract 1 from both sides, square and then subtract 1 from both sides, and you get x is greater than or equal to -1. So that's the domain of f of x. Domain of g of x is going to be 3, set what's underneath the radical, greater than or equal to 0, and then solve. Minus 3, so that would be negative x is greater than or equal to -3. Then divide by a negative. So this one we actually get x is less than or equal to -3. So if I look at this, positive 3. So if I look at this, I kind of have a band. My values are between -1 and 3 inclusive. So the domain of h of x is between -1 and 3. So this is kind of an and function when we're talking about kind of compound inequalities. Find a new function rule for h of x. So if we're multiplying these two together, then that means we've got, let's see, square root of 1 plus x times 3, square root of 3 minus x. And we said h of x is now this. All right, so when we multiply these together, got to remember when we multiply that these, essentially, we've got to multiply the same radical and radicand. I'm discussing this because this is specific to the square roots. In a problem where we would have maybe a different radical and a radicand, we have to adjust those. I like to think of this as 1 plus x to the 1/2 power and 3 minus x to the 1/2 power. Remember, those mean the same thing when we go through and multiply. When we go through and compare radical functions to rational exponents. These two are the same thing. So when we multiply these, we get a certain scenario or situation to happen. I'm going to pause the video. I need to delete some videos because I'm about to hit my limit on my computer. So there will be a shortcut here in a second. Sorry about that. All right. Sorry about that. I got a warning about the amount of space that I had left. Coming back to when we multiply. When we multiply 1 plus x to the 1/2 power and 3 minus x to the 1/2 power, these both need to have the same denominator to be able to multiply them. So combining them essentially under the same radical, again, same radical, they have to have the same root. So we're going to take 1 plus x times 3 minus x, and then again, all under the same radical are all raised to the 1/2 power. So all this means the same thing. If I multiply this out, I get the square root of, let's see, 1 times 3, so I'm going to have minus x plus 3x, so that's plus 2x, and then it looks like minus x squared. And then normally what happens is we go ahead and just put this in standard form order. So this would be -x squared plus 2x plus 3. There we go. Use the result from part 10 to evaluate h of 2 and h of 4. So h of 2, plugging in h of 2, So h of 2 is equal to square root of negative, or opposite, excuse me, of 2 squared plus 2 times 2 plus 3. Negative 4 plus 4 plus 3. Those two cancel. So let's square root of 3. h of 4 is outside the domain. It is outside of the domain. So we would have no solution. In this next one, we now have a function where we're dividing, and then we have kind of that extra component or extra piece. So to determine the domain, there's no issue with this function as I'm not taking any even root. I'm not dividing by anything within this function, g of x, not taking even root, not dividing. However, g of x is the denominator of this new domain, sorry, of this new function, h of x. So we need to set x minus 3 not equal to 0 and then solve. So I set it not equal to 0 and then solve. Add 3 on both sides. So you get x cannot equal 3. So the domain of h of x is any real number except 3. This slash is what you use in set notation. So if I was doing the set of x's such that, didn't give myself enough room. Nor did I erase really well. Sorry about that. The set of x's such that x is an element of the real numbers except 3. Find a new function rule for h. So dividing by this, so I have x cubed minus 3x squared plus 2x minus 6 all over x minus 3. So this is h of x. Depending upon your course previously, in Algebra 2, or pre-calc, or depending on where you come from, you might want to check to see if x minus 3 is a factor of this, if it factors out, because it could make your life a lot easier. If I factor, so let's see, if I do factor by grouping for this, I'm going to end up with, let's see, if I pull out an x squared first, I'm left with x minus 3, that's already looking promising, plus 2, and I get x minus 3, yep, definitely looking like it. So if I factor out that x minus 3 from both of these, I get x squared plus 2. So I want to point out a very interesting scenario here, because we can cancel this x minus 3. A lot of students think that if you cancel it, it's no longer a problem. I don't need to worry about it when I plug in the number. You do, because you plug it into the original value whenever we're plugging it in. It does simplify to this, which is a lot easier to work with when we're evaluating these numbers, but h of 3 is not in the domain. So h of 3 is no solution. Even though it looks like it would give us one here, remember, we're still dividing by this value here. Dividing by 0, we can't divide by 0. So h of 3 is no solution. H of 10, though, is equal to, you're welcome to use this, the simplified version as you go through. So I have 10 squared plus 2. 10 squared is 100. 100 plus 2 is 102. So evaluating 10, we get that. And then down here, I actually just talked about what we just did. So feel free to read that. Next video, I will go over example 3 and the composition of functions. Have a wonderful day.